Hello everyone, my name is Pandya Kush. I am from Marwadi University. This video is related to conceptualization, which is part of ICE subject, and this is given by our Professor C.D. Parmas. My topic is digital modulation or digital carrier transmission. What I will discuss in this video. Firstly, I will give overview about digital modulation. Then I will tell you the first part or a first technique of modulation, ASK, then about FSK, then about PSK. And then we will see some visuals and some comparisons between all these techniques. So what is digital modulation? It is a process to convert a digital signal into a specific parameterized analog signal. Parameter means amplitude, frequency, or a phase. As you can see in this image, this digital signal is transmitted over this carrier frequency, and as an output, we are getting an analog signal. So these are the main three techniques of digital modulation: amplitude shift keying, frequency shift keying, and phase shift keying. This QA means quadrature amplitude modulation, which is the combination of amplitude and phase modulation. About this, I will also tell you in the last. So first technique is amplitude shift keying. In this technique, we are getting an output signal according to amplitude of transmitted digital signal. Like in this picture, you are seeing this data like 1010 101, and this is the carrier frequency. This data is transmitted over this frequency, and according to that, when the out input is high, at that time only we are getting an analog signal according to its amplitude only. So for that, bandwidth requirement is 1 plus D into S, where S is the signal rate and D is the parameter which is depends on modulation or its filtration. Amplitude shift keying is used over optical fiber, and this is also sensitive to noise, distortion, and some propagation delays, because noise are only affected by amplitude. So if there is noise in the environment, then we are not able to get according output in the amplitude shift keying modulation. Next is the frequency shift keying. In this modulation, we are having two frequencies. So bandwidth requirement for this modulation is higher than previous one. As you can see in the formula that here we are adding 2df, means the extra frequency of the from the environment. And you can see in this picture that this digital data we are transmitting on the carrier frequency. So we, as an output, we are having two frequencies. This one is higher frequency and this is lower frequency. This modulation is commonly used in the telephone lines and in the remote metering application. And this modulation technique is a noise immune technique. because noise cannot affect on the frequency. It can only affect the amplitude. Next is the phase shift keying. In this modulation, as the data changes from 0 to 1 or 1 to 0, signal changes its phase from 180 degree to 0 or 0 to 180 degree. In this picture 1011. So as one is changing from 0, so we can see here that signal is going up, but as it changes, then again it continues from the down. So the receiver circuit for this modulation is quite complex, because to determine where the phase change and how much the phase is changed is difficult to determine as compared to see that amplitude is changed or frequency is changed. And bandwidth requirement for this is same as amplitude shift keying. And this modulation technique is used in wireless LAN, RFID, and Bluetooth communication. So this is a comparison between these three techniques. As I have told you that ASK is the poor noise immune and FSK is the noise immune, and PSK is used for high bitrate applications. So let us see some visuals about these techniques. This is amplitude shift keying. Where the signal is high, then there is transmission of any data. This is about frequency shift keying. And this is about PSK. Where data is changing, the signal is also changing its phase from 0 to 180 or 180 degree to 0. As I have told you that QAM technique. So the QAM means we have combined amplitude and phase together to give modulation, and we have also some sub parts of all these techniques, like BPSK and BFSK means the binary phase shift keying or binary frequency shift keying. So these are the digital modulation techniques we are using to transmit digital data in analog form. The references are given in here, and my learning from this is that I was not much aware about application of these modulation techniques. So I have learned that from this. So that's it about my side. Thank you.